Good afternoon, class. In today's video, what I'd like to do is to go over some example problems from the Stoichiometry homework. This is going to be covered number 6, number 11, and number 17. So to start off, to make sure that you understand what's going on, let's go over a few things. We have C5H12, or let's start with the chemical reaction. We have C5H12 decomposing into C5H8 and 8 hydrogen gas. So the next part we need to do is to take a look at some of the basic information that we have, which is why I barely got this to fit in the screen. So let's go with this. We've got the density of C5H12, which is 0.620 grams per milliliter. The density of C5H8 is 0.681 grams per milliliter. The density of H2 hydrogen gas is 0.0899 grams per liter. This is important. We're going to cover that in one of these examples. And the molar mass of C5H12 is 72 grams per mole. Mass of C5H8, 68 grams per mole. And the mass of hydrogen gas, which is 2.016 grams per mole. So now let's go into some of the example problems that we have with that are in that homework assignment. So we have number 6 right here, which is how many liters of hydrogen gas can form when 4.53 times 10 to the third milliliters of C5H8 form. So when you've got that, what we do is we start with our normal milliliters, so with basically this number here from the problem itself, and we're going to convert it. We're going to go from milliliters of C5H8 to liters of hydrogen gas. So in order to do that, remember what we need is we need to have a unit that is able to convert quickly and efficiently from C5H8 into H2 gas. So in order to do that, that unit is going to be the mole. Now this one, unlike the first one in my previous video, like the one over there, the mole ratio was 1:1. In this case, it's going to be 2:1. So you have to be careful about that. And where did I get that mole ratio, by the way? From here in the chemical reaction formula. So that's where this 2 is. Basically what this chemical reaction is saying is that for every mole of C5H12 that you've got, you're going to produce 1 mole of C5H8 and 2 moles of H2 gas. So something to think about. So as we go through these examples, keep that mole ratio in mind. So we're going to start by converting milliliters of C5H8 into grams of C5H8. So we multiply by the density. Then we divide by the molar mass so that we can get rid of the grams of C5H8. From there, we're going to use our mole ratio to convert from moles of C5H8 to moles of hydrogen gas. From there, we basically do the opposite operation, or we're doing the opposite of what's going on here, which is converting moles of hydrogen gas to grams of hydrogen gas. And finally, grams of hydrogen gas to liters of hydrogen gas to get an answer of about 2.03 times 10 to the third liters of hydrogen gas. Okay, so that was number 6, and that's probably going to be the longest part of this example because the rest of this is going to look fairly familiar. So I'm just going to keep going with number 11. Most of the steps are going to be pretty much the same. So in number 11 it says how many milliliters of C5H12 are needed to form 97.3 milliliters of C5H8. So in this case, what I'm going to do is I'm going to start with 97.3 milliliters of C5H8, and then we'll go through the same steps, converting C5H8 into moles, and then we go over here to our mole ratio, 1 mole of C5H12 to 1 mole of C5H8. And then we do the same thing, we cancel out our moles, convert it to grams, and grams to milliliters of C5H12 to get a final answer of about 113 milliliters of C5H12. Moving on to our third example, we have how many liters of hydrogen gas can be made from 4.53 times 10 to the third milliliters of C5H12. Hopefully, what you're noticing is that this one looks somewhat similar to this one. And that's one of the reasons why I wrote the question itself in green to show you that these two are kind of related. They're not exactly the same, but they're close enough. So we start with our 4.53 times 10 to the third milliliters of C5H12, and really, if you'll notice here, the steps are kind of the same actually. The only difference is that this density here is 6.2 grams per milliliter instead of 6.81 grams per milliliter. So a little bit of differences, and you'll actually get to see it. There's actually so you can kind of see the difference between this answer and this answer. So it's basically all of the same thing. We're going to start with our milliliters, converting it to grams, converting grams into moles of C5H12, using our mole ratio, because it's the same thing here, right? 1 mole of C5H12 will form 2 moles of hydrogen gas. So we have our 2 mole ratios here, converting it back from moles to grams, and from grams, finally, 2 liters of hydrogen gas. And as you can see, there is a slight difference. Instead of with C5H8, you'll form a little bit more hydrogen gas than you would over here. So there is a difference. It does actually matter which chemical you use. So I thought I'd point that out, but also to show you that a lot of these examples, they look kind of the same in terms of the work that's needed to actually solve it. So I thought I'd point that out. What I also thought I'd do is, give you a chance to see it. These are some of the problems that you could be solving for. If you need to pause this video at any point to really zoom in on each of the steps that I took to actually solve this, go for it. The last thing that I did want to point out was that over here, what I did was I rounded this all to about scientific notation as best as I could. So in this case, I think I might have missed some of these. It might not be exactly scientific notation, but that's why if it doesn't look, it looks kind of clean in this one. It's a fairly decent amount of, like a fairly even number. It's not. There's a lot of decimals that go into it, but at least it's in as much scientific notation as I'm going to probably get. So I thought I'd feature that as a sample of a bunch of problems from the different parts of that homework assignment. So study hard, and I'll see you in the next video.